In this lesson, you'll learn everything about fractions, and you don't have to go to any other video to understand about it. So we'll give you all the details about it with examples and with homework. All right, so let's begin. So what are fractions? Fractions, by the name of it, it's like a fraction of something. So something that's less than a whole. So you can draw something, for example, a pie, but you don't have the whole thing. And when we deal with fractions, they have to be equal in sizes. So if I draw a third, I can't go like that, and then I have, right, it's not going to be fair. So instead of that, I've got to divide it equally. And let's say I only want one piece. And so to represent that in terms of numbers, we have similar to the divide symbol. The divide symbol is similar, right, because we're trying to divide stuff. Right, so we have the line here. Now, how many pieces do we have? Well, we have 1 here, 2, 3. We have 3 pieces, so in the bottom, we have to put the 3 down. And the number of pieces that we have colored in, the ones that we want, goes to the top. So we only have 1 piece colored in. We call that the numerator. And we call the bottom the denominator. So what is the numerator? The numerator is basically the selected number of pieces that we want. And the denominator is the total number of pieces. We don't necessarily want the whole thing. In fact, we don't want to have the whole thing. Now, how do we say this fraction? Well, in most cases, we can say the number over the bottom. So 1 over 3. We can say that. Or if you're from Britain, we can say 1 on 3. In other cases, we can say 1/3. Okay, now we're going to give you a few other ones to talk about. What about 1 over, like this one, 1 and 2? Well, we can say 1/2, or we can say 1 over or on 2. What about 1 over 4? 1 over 4, or 1/4. So most of the time you can say the number over the other number. Okay, so what situations can you use the other? Well, right. So if you are doing like over 2, over 3, over 4, so these are halves, that's a quarter. These are third, and then for 5, it's fifth. 6 would be sixth. So it's like positioning. So if I have 21 over 30, we can simply say 21/30. The thing is, we don't want to, these get too long at some point, so it gets more complicated. Maybe just easier to say 21 over 30. Now the next thing we should be talking about is how, when you divide a fraction further, what happens. So let's say we have one fraction here. We have a 1/2. Now what happens if I want to, so let's do another one. Let's do this red. So right here, they're both 1/2 right now, right? Now, but what happens if I divide this further by another half? So each piece I divide by half. So it's no longer 1/2 because I have 4 pieces. So the denominator is now 4. Now, how many are colored red? Well, there's 2 colored red, right? We have 1 here and 1 here. So the numerator is 2. Okay, but it's still, if the line wasn't there, if this line wasn't there, we haven't actually divided more or less. It's just the pieces get smaller. So we can say these are basically the same. These are equal. And these fractions are called equivalent fractions. When you want to share with more people, you have to divide each piece equally. Okay. So we can then, you notice the relationship, it's like multiplication. because you're basically multiplying by the number of times you are dividing the piece further. So let's say I have the quarter, and then I divide that by half again. Then I have an eighth. Each one is an eighth. Now if I color the half again, I have now 4/8, which is also equal to 2/4, which is still equal to 1/2. Now these are all just multiplication or division. Now if I go down, I'm dividing, right? If I'm going up like this, I'm multiplying. You have to make sure that when we're trying to expand these equivalent fractions, they have to be multiplied by the same number. So that means if I have 1/3 and I want to expand it to over 9, I'm multiplying by 3. So I must multiply by 3. I get 3/9. And if you look at this, how do we draw a ninth? Right? So we know we're trying to divide each piece by 3. So we just have to divide each piece by 3. I mean, it's not perfect, but if I were to, let's say, if I were to go from 1/3 to over 9, and I'm multiplying the bottom by 3, and I'm only multiplying the top by 2, I get 2/9. And you see, if I'm only coloring 2 of those pieces, these are different fractions. So you've got to make sure that. Okay, so next thing is, if you know how to expand and simplify fractions, what's the next thing? Well, the next thing would be try to add these fractions. Let's say we have 1/2 plus another 1/2. Well, if you try to add 2 halves together, what do you think you get? A whole, right? Yeah, because then they put together, then you get the whole thing. So you get a 1. But then how does that work? So when you're adding fractions, the number of pieces stay the same, right? The total number of pieces. So it's always going to be over 2. Because you cannot add a half with a third. Because although you have 2 pieces, they're not the same amount. It's hard to tell people, I have 2 pieces, but they're not the same. So they can't compare whether you have 2 pieces or less than 2 pieces. Because when we can say I have 3 pieces or 10 pieces, they have to be fungible, meaning they have to be the same size, right? So let's say I'm talking about dollars. I have $1 here, I have $1 here, I have $1 here. So I can say if I add them up, I have $3. But what if I say I have $1 and I have a nickel and I have a quarter? These are different in values. I can't say I have $3, right? I just can't because they're not the same. So same thing with fractions. We cannot just add if they are not the same size. So when we know that the denominator is the same, all we have to do is add the numerator. So 1 plus 1 is 2, and we can simplify by dividing by 2, and we get a 1. Okay, but it gets more difficult as we are trying to do other larger numbers. Let's say I have 2/10 plus 6/10. Right, again, the numerator stays the same. Again, the denominator stays the same. Now we're just adding 2 and 6 together, and we'll get 8. Now, 8 and 10, we can reduce that by 2 because they're both even numbers. So we can divide that by 2, divide this by 2, we get a 4/5. Now, if we were to draw this, I have 10. Okay, so 2/10, we want 2 pieces. And then we have a 6 here, 1, 2, 3, 4, 5, 6. So if we add these up, we can just simply bring these 2 over here, and we'll get 1, 2, 3, 4, 5, 6, 7, 8. Now if we reduce it further, I'm just going to draw 5 pieces. So 5 pieces. So we want 1, 2, 3, and 4. Because then if you divide them further in 2, it's the same as the other one. Now, what if we have denominators that are different? What if we have a half and we want to add 2/5? Okay. In the drawing, we have a half here and we have 2/5 here. Now, you can't simply add them. If I were to add them, this would look like that. If I were to bring these two pieces over, we can't do that. So the one way we can do that is by making all the pieces the same. If the pieces are all the same in size, then we can add them. So how can we do that? Well, one thing is to try to see if we can make one of the pies similar to the other one. For example, can I break the 1/2 into pieces similar to the one in 2/5? Well, if I were to just simply draw the 2/5 like that, we can do that. But then there's a problem because some pieces will be greater than the others. So, because then if you look at the other one, if we take the 2/5, so if I were to continue this line here all the way, I have a half. So this half and this half. But the thing is, I have cut this bottom piece in half, but the other pieces are still a fifth. So this piece, for example, is actually 1/10 because I've taken this 1/5, originally it was 1/5, right? And I have divided into 2. So I must also divide everything else in 2. So now the whole pie becomes 4/10 because we have 4 selected. Now in that case, we have to divide the 1/2 into tens as well. Like so. We will notice that the 1/2 becomes all 5 pieces, 5/10. And then the 2/5 becomes 4/10. And you see these are equivalent fractions because when I multiply the 1 by the 5, I get 5. And then I do the same with 2. I multiply 2 by 5, I get a 10. Now similarly, I multiply the 2 by the 5, I get a 10. And I multiply the 2 also by the 2, I get a 4. So you notice that each of these fractions we are multiplying by a different number to get to a common denominator. And we call that the lowest common multiple. So how do you find the lowest common multiple? Well, we first have to find out what a multiple is. So that leads us to the next discussion. Lowest common multiple. So we first want to talk about what a common multiple is. When you have more than one integer, you can have a common multiple because, for example, 2 and 3. When we write all the multiples out, let's say for 2, we have 4, 6, 8, 10, 12, 14, 16, 18, and 20. That's like from your multiplication table. Now for 3, you have 3, 6, 9, 12, 15, 18, 21. Notice that the 6s, the 12s, the 18s are repeated. You see the number twice. These are all the common multiples. And in fact, you can keep going. And there's infinitely many of these multiples. Even at some point you have 2,000 and 3,000. That's also a multiple because you're multiplying each of these by 2, by 4, by 6, and so on. So similarly to the 2, well, you're multiplying by 3, then you're multiplying by 6, then you're multiplying by 9 to get to that stage. Now, how do we ensure that we will definitely get to 6? Well, you do something called multiplication. I'll show you. When we have these two numbers, you notice that we cannot simplify them. Like in some cases we can, right? Like 4 and 6. You can divide both. We can draw like a little L, put the divisor here. So we divide by the 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. Now you're at this stage again. You cannot further divide them. So you just take these numbers outside and you multiply them. And so you have 2 times 2 times 3, and you get 12. But that's only for 4 and 6. But if we have 2 and 3, we cannot simplify them. There's no number. So we just simply multiply them and we get 6. And you can see that. Now, just to show you what happens to 4 and 6, 4 will be 8, 12, 16, 20. 6 would be 6, 12, 18, 24, right? So 12 would be the lowest common multiple. But then we also have a 24 at one stage, but that's not the lowest common multiple. Right, so if we know how to do that, we can convert any fraction into their common denominator, so we can add and subtract. So moving on, let's do a couple right here. Let's do 1/4 plus 5 over 6. Okay, and we know that the common multiple here, or the lowest common multiple, is 12. So we can have over 12. Now we just have to figure out what 4 multiplies into to get to 12, which is 3. So we're going to do the same with the 1. Get a 3. Now the 6 multiplies by 2 to get to a 12. So you've got to multiply the 5 by the 2 to get to a 10. And so when we do add them, we get 13 over 12. Now when we have 13 over 12, that's not a normal fraction. It's called an improper fraction. Why is that improper? Because you have the numerator greater than the denominator. So the numerator is greater than the denominator, because then that's greater than 1 already, right? Fractions are usually less than 1 whole. So in that case, you can ask this question. So 13 over 12, how many wholes are there in 13? Well, only 12 are in 13. There's no double that. So that means if I take out a 12, I have 1 whole. 1 whole plus whatever's left. You have 13 minus 12. So you have basically 1 over 12. So in that case, we can rewrite this as 1 and 1/12. So which we call this a mixed number. So in a mixed number, now there's a question. How do we get from a mixed number back to an improper fraction? So we can give you an example here. Let's say we have 4 and 3 over 4. So we have 4 individual items, and we have 3/4 of an item. So what you're going to do is keep the 4 down, because you're going to have 4 pieces in each whole, right? Now you're going to have to figure out, okay, well, these 4 individual wholes, we're going to have 4 pieces each. So you're going to multiply the 4 wholes into 4 pieces, and you're going to add whatever's left. So that goes in here. So you have 16 plus 3 over 4, or you have 19 over 4. So this is converting from mixed number to improper fractions. Okay, let's go from an improper fraction to a mixed number again. So let's say I have 14 over 3. So how many wholes are there, right? So we want to think about how many 3's can fit in 14, right? So we have 3, 6, 9, 12, 15. 15 is more than 14, so we must be 12, right? If it's not the case, that means we have 4 wholes, and 4 times 3 is 12. Then we have 2 left, because you have 14 minus 12 is 2. You have 2 over 3. So 4 and 2/3. And that's converting from improper fraction to mixed number. Now we've covered addition, so let's cover some subtraction. So let's say we have 7 over 9 minus 2/3. 3 and 9 are not a common denominator. So we just bring it over here, simplify that. 3 divided by 3, it's 1. 9 divided by 3, that's 1. Now multiplying the outside numbers, and we get 9. So we know that this is going to be something 9, something 9, right? So we have nothing changes for the first fraction. Now the second one, 3 must be multiplying by 3 to get to a 9. So we're going to multiply the 2 by the 3 and we get a 6. We know that the answer is going to be over 9. And we just do 7 minus 6, and that's a 1. So 1 over 9. Now what happens if we are trying to multiply fractions? So multiplying, and you want to be doing dividing. So when you're multiplying fractions, let's say we are doing 1/2. So that's 1 and 1/2. So let's say I want to have 2 of these. Let's say I want to multiply by 2. What that means is I'm adding 1.5 by itself. So I have another 1.5. So if I put these together, I have 2 wholes, and I have a half plus a half, that's another 1. So I add them together, I have 3. So how do I get from 1/2 times 2 to a 3? When we do this, you don't want to do it 2 separate times, right? So we want to convert this 1/2 to 3 over 2. So you want to convert any mixed numbers into fractions. And by fractions, I mean improper fractions. So then we have 3 over 2 times 2. Now when we're multiplying fractions, we don't need to be doing the common denominators, because I'll show you why. When we're adding, they have to be the same size because you're stacking them. But multiplying, you see these 2 halves become a 1 anyway. Because then there are times where when you're multiplying fractions, like smaller than 1, they could complete a whole at times. Sometimes not, but sometimes they do. And so multiplying fractions is actually quite simple. All you have to do is convert the whole number into a fraction. Because the 2 here, it's basically 2 over 1. There's no fraction. It's a whole number. And when you're multiplying, you just multiply horizontally, and you get a 6 over 2. Now what that means is I'm trying to break the wholes into halves again. So I have 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So I have 6 halves, but they're equal to 3 anyway, because then they can become a whole. Okay, so that's how multiplication works. Now let's say we have 1/4 times 1/3. In terms of visuals, we have 1/4. And if you want to multiply by 1/3, meaning you only want to get one of those thirds. So you're dividing by 3, right? A fraction is like division anyway, because if I have a third, I have this whole, but I only want 1/3 of it. So I'm dividing the whole thing by 3 and only getting one of those pieces. So if I have 1/4 already, that means I'm getting less than a quarter. I have to divide each piece by 3. So let's do that. Now, dividing each piece by 3, I have 12 pieces now. Each original piece has 3. I have 4 of those quarters. So I have 4 times 3, which is 12. So I'm just multiplying horizontally. Now, but I only want one of those pieces. I don't want all 3 of those. So I'm going to color in this as blue. Now, the black, I don't care anymore. Now, I only have 1 selected, so I have 1 over 12. So again, I'm multiplying horizontally. What about divide? What if, let's start with a whole number. Let's say we have 2, and we'll divide by 4. Okay, start with a whole number first. When we have two wholes, we want to divide into 4 equal pieces so that we can share with 4 people. So what essentially we're going to do is, the way we can find 4 pieces is we divide this, let's do that in blue. We divide them equally in half so that I have 1, 2, 3, 4 pieces. And so when we do write this, it's like saying 2 divided by 4, because that's what fractions are, right? And I'm simplifying this. I'm going to get half. So each piece is a half. That's a half. That's a half. That's a half, and that's also a half. Now another way to write this is you can say 2 multiplied by the reciprocal, which is 1 over 4, because you have 4 over 1, but then you want to flip it to get 1 over 4. So it's called a reciprocal. And so we have 2 over 1 times 1 over 4. And if you just multiply, you get 2 over 4. And then again, you're back to 1/2. Now, what happens if we don't actually have whole numbers? Let's say we have a half divided by 2. So I have this half here, and I'm dividing by 2. I'm cutting this in half, and I'm getting one of those pieces. Then I have a quarter, right? Now a half divided by 2 over 1, which is the same as 1/2 times 1 over 2, which is 1 over 4. So in that case, we have the same answer. Now one last thing is, let's say we have 2 here, and we want to divide it by half. That's one of the more difficult to grasp. So if 2 wholes, what this means is, now I'm dividing by half. Instead of dividing by 2, let's say I divide by 2. Then I'm taking this here as one of those pieces, and then this as one of those pieces. Then I have 1. But I'm dividing by half, meaning I'm treating this whole thing as one of those pieces. Now, what happens to the other part? Well, that means I need to add exactly 2 more of these so that I can take this as half of it. So this will be half of it, and this will be the other half of it. Now, so then I have 4. Now, how does that work in terms of the math? So I have 2 over 1 divided by 1/2, which is, then I flip it. I have to multiply by 2 over 1. Now, multiplying this horizontally, I get 4 over 1, which is just 4. So when we divide any number by a fraction, I actually gain more than I start with.